Hi there. This is section 5.2, LCMs, LCDs, addition and subtraction. Finding LCMs. To find the LCM, use each factor the greatest number of times that occurs in any one prime factorization. So example 1, find the LCM of 48 and 54. So when you're looking at multiples, you can sit there and write all the times that you multiply 48. So 48 times 1, 48 times 2, 3. And the goal is to find the smallest number that you can get from those two numbers. A trick to do so is to prime factorize. You can do a prime factorization tree. So to begin, you want to think, what two numbers do I multiply to get 48? So you can think of any two numbers, as long as they work, you multiply to get 48, it's fine. So I thought it's even, let's start with 2. If I divide by 2, it's 2 and 24. Now your goal is to get to a prime number. Maybe I should write down what prime means. Prime means that its only factors are 1 in itself. Such as 2, 3, 5, 7, 11, 13, 17. When I multiply to get any of these numbers, I can only get them by multiplying 1 and itself to get itself in return. Okay, back to our question. Now let's prime factorize 24. What two numbers give me 24? Well, 6 and 4 give me 24. I can get 6 from 2 and 3, and we stop once we reach primes. I can get 4 from 2 times 2. 2 is a prime. Okay, let's go ahead and list all of our values. So for 48, we got 2, 2, 2, 2, and 3. Let's do 54. Okay, well, it's even, so 54 divided by 2, we get 27. 2 and 27. 2 is prime. I can get 27 from 3 divided by 9. So 3 times 9. 3 is prime. I can get 9 from 3 times 3, and 3 is prime. So I can get 54 from 2, and you want to make a list. Now, if they repeat, you want to write it under the repeating number. So we have a 2, we have a 3, we don't have another 3, and we don't have another 3. So we can do this to keep track of our numbers. Now you bring them down and multiply. So I have 2 times 2 times 2 times 2 times 3 times 3 times 3. And let's multiply them out. So I have 2 times 2 times 2 times 2 times 3 times 3 times 3. We get 432. So that is the smallest number that can be divided by both 48 and 54. That is the lowest common multiple. So let's take a look at example 2. Let's find the lowest common multiple for 6x squared y and 4x cubed y. Okay, let's begin with our numbers. So what's the smallest number that can be divided by 6 and 4? Let's do a factor tree. So 6, I can get it from 2 times 3. I can get 4 from 2 times 2. So if I create a quick chart with various factors, I have 2 and 3, and you get 4 from 2 and 2. Let's bring down all our numbers. 2 times 3 times 2, we get 12. So for our numbers, it's 12. When you're looking at your variables, you want to pick the highest one of each one. So between our x's, I have x cubed as our highest one. Between our y's, they're both to 1 degree. So this is our LCM for those two numbers. Let's recall about addition and subtraction with like denominators. To add and subtract when denominators are the same, add or subtract the numerators and keep the same denominator. That's important to remember, especially since we just did a lot of multiplication in the last section. All right, so recall, when we're adding a fraction, we want to have the same denominator. You can always multiply by a special one so that you can create the same denominator. So if we have 4 and 5, I can multiply it by 7 over 7. And we can multiply the other fraction by 5 over 5. So that we get 7 times 4 is 28. 7 times 5 is 35. 5 times 3 is 15. And 5 times 7 is 35. Okay, now we can go ahead and add 28 and 15. You get 43. 43 over 35. We needed to create that common denominator so we can just add the numerators. Okay, so all those rules of adding and subtracting fractions that you learned in the past apply to polynomials. So in example 3, we're asked to add. So to add, we need to have the same number, or in this case, variable or expression in the denominator, and we do. So we keep that w, and we add our numerators. So I have 5 plus 6 plus w. Well, I can combine like terms so that I can only add the 5 and the 6 to get 11. So that we have 11 plus w over w. And that is our answer. Let's take a look at our next example. So recall, to add fractions need to have the same thing in the denominator. In this case, they do. So I can go ahead and add my numerators. So that I have 3x plus 1 on the bottom, or minus 1 on the bottom. And in the numerator, I have 3x squared plus 4x minus 9 plus x squared plus x minus 3. Okay, let's add my numerator. In my numerator, I have x squared plus 3x squared gives me 4x squared. 4x plus x is 5x. Negative 9 minus 3 is negative 12. All over 3x minus 1. Addition and subtraction with different denominators. To add and subtract rational expressions with different denominators, 1. Find the LCM of the denominators. This is the least common denominator. For each rational expression, find the equivalent expression with the LCD. To do so, multiply by 1 using the expression for 1 made up by factors of the LCD that are missing. 3. add or subtract the numerators. 4, simplify. Okay, so we have example 4, and we're being asked to add 5x divided by x squared plus 5x plus 6 plus the fraction of 3 divided by x squared minus x minus 21. Okay, I need to create a common denominator. Let's first factor each one. Let's factor our denominators. Okay, in my first one, I see, and you can factor if I think of two numbers that multiply to be 6 but add to be 5. 3 and 2 works, so this multiplies to be x plus 3 and x plus 2. In my other fraction, or denominator, what numbers multiply to be negative 21 but add up to be negative 4? 7 and 3 make 7 negative, so I have x minus 7 and x plus 3. So take a moment and only look at the denominators. So we need to create an LCD, which is the LCM of your denominators. So make it so you have every one of those parentheses accounted for. So I have an x plus 3, and we only have one of them. So x plus 3. I need an x plus 2, and I need an x minus 7. This is our LCD. So what we're going to do next is we're going to multiply each fraction so that we get the same thing in the denominator. If it already has it, I don't need to include it. So what we'll do is multiply by a special 1. So for the first fraction, we have 5x divided by, let's write the new version. I have x plus 3, our new factored version, and x plus 2. Now looking at our LCD, let's take a moment to look at it. It has the x plus 3, it has the x plus 2, it's missing the x minus 7. So let's go ahead and multiply by an x minus 7 to the top and to the bottom. Now that's just 1, right? That is just 1. So we're not changing the value of our fraction, we're just disguising it. Okay, let's continue. Looking at my other fraction, I have 3, and my denominator I have x minus 7 and x plus 3 in factored form. Looking at my LCD, we see that it has an x minus 7 and it has an x plus 3. It's missing an x plus 2. So let's multiply top and bottom by an x plus 2. Okay, let's go ahead and clean this up. So in the denominator, we have created our LCD of x minus 7, x plus 3, and x plus 2. Right? Just like we have here in our LCD. Okay, what do we have in our numerator? In our numerator, we have x minus 7 times 5x plus 3 times x plus 2. Okay, let's actually multiply our numerator so that we can add them. So let's multiply in that 5x so that we have 5 times x is 5x squared. 5 times 7 is 35x. Let's multiply in that 3. 3 times x is, well, it's a positive 3. So we have 3x plus 6. And in my denominator, I have my LCD. We can write LCD from time to time when we're building our work. Let's clean up our numerator. So I have negative 5x, or positive 5x squared. 5x squared And then we can add up those x's. So we have negative 35x plus 3x. We have negative 32x plus 6 all over x minus 7, x plus 3, and x plus 2. Let's do example 5. So this one isn't as, I wouldn't say wordy, but as with heavy writing, we see our denominators are almost the same, right? Remember our rule that we can always factor out a negative 1. So if I factor out a negative 1 here, this now gives me x minus 3. And now I've achieved that. So what is our LCD? You want to think, I want to have everything covered at least once. So I have my x minus 3 on both of them, but I need to consider that negative 1. That is my LCD. So that second denominator does have that LCD. So that one checks out. But this first fraction, it's missing that negative 1. So let's multiply in that negative 1. So I have negative 1 over negative 1 times 5x over x minus 3 minus 2 divided by negative 1 times x minus 3. Okay, let's multiply in my numerator. So that I have negative 5x divided by negative 1 times x minus 3. And on the top I have minus, and I'm subtracting all of that too. So that I have negative 5x minus 2 divided by negative 1 divided by x minus 3. Now we see that in my numerator we can factor out a negative 1. Let's go ahead and do so. If I factor a negative 1, I'm left with negative 1 and 5x plus 2. My denominator I have negative 1 times x minus 3. You can still clean up and cancel so that you're left with 5x plus 2 divided by x minus 3. One more example. Perform the indicated operations and simplify. Okay, so let's look at this problem. We have x minus 2y divided by y minus x minus 3x minus 3y divided by x minus y plus 2x minus y divided by x minus y. Okay, so we're trying to find our LCD. I'm taking a look at all these denominators, and I see I have an x minus y and x minus y, and this one is being a rebel, right? I can create that x minus y by factoring out a negative 1, and I get x minus y. But then all of these are now missing a negative 1. So what is our LCD? Negative 1 times x minus y. Okay, so let's go ahead and create that same denominator for all of them. So that I have x minus 2y divided by, well, I have negative 1 or negative x minus y minus, I need to incorporate my LCD, so I need to multiply it by a negative 1 top and bottom. So that I have 3x minus 3, and the bottom I'll have x minus y. And then I have to multiply that negative 1 to the top and bottom to my 2x minus y, x minus y. All right, so let's take a look at each one separately. For my first one, nothing has changed. So I have x minus 2y divided by negative x minus y. For my second one, I have a negative times a negative. So let's together make a positive. So I have positive 3x minus 3 divided by negative x minus y. Now, on the other side, I have a negative that I need to incorporate in. So I have plus negative x minus y on the bottom, and then I have negative 1 times 2x minus y. Okay, let's clean this up. On the bottom, I'm just going to, it's not too much, negative x minus y. And I have x minus 2y plus 3x minus 3, multiply in that negative 1. So I have negative 2x plus y. Let's go ahead and clean up our problem. Do I have any like terms to add? Yeah, I have my x's. 1x minus 2x, we're left with negative x. My y's, I have a 3 right here too. So I have 1 plus 3 is 4, minus 2, we have 2x. And then our y's, so I add up my x's. My y's, I have negative 2 plus 1 minus y minus 3 all over negative x minus y. And there we have it. That's it for section 5.2, LCMs, LCDs, addition and subtraction. Thanks.